Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM. That means it is another Friday night, and this one is January the 26th, 2018, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal Time, that would put it at 2 o'clock in the morning, Saturday morning, January the 27th, 2018. My name is Marty Kunz with my co-host.
Good evening, it's Nick Evetts. 2 Echo Zero, Lima Uniform November.
It's a Friday night. How's your Friday night doing, Nick?
Oh, my Friday night's totally peachy.
All right.
I've got some... Well, the thing is, if you're not in the chat room, get in the chat room, okay?
Yes.
Because prior to the show starting, we've had a really good conversation going on about radio telescopes and stuff. So originally, I was going to discuss with Marty adaptive optics for astronomers. But I kind of changed my mind a bit because there's a couple of things going on which I thought would probably be much more fun. And of course, with the conversation that was going on pre-show, I thought, you know what, this is too good of an opportunity to miss.
Right.
Now, the other thing is, of course, I picked up a story thanks to some of my friends down in New Zealand. Now, I don't know if Marty's seen this story, but new research from New Zealand shows the first jet from a massive young star that's been detected from outside our galaxy.
I saw that, but I didn't get a chance to read it yet.
Oh, I did. It's a fascinating story. So this is from the University of Canterbury in New Zealand, and new research is showing that they've actually finally imaged something. It's a massive young star. These massive stars are very, very fleeting in their existence because they're burning their fuel so quickly on a cosmic scale, like they're here and gone.
Depending on the size of the star, though.
Yeah, the more massive the star, the faster it burns its fuel.
Yep.
Now, Marsden Fellow Dr. Anna MacLeod of University of Canterbury School of Physical and Chemical Sciences saying that this discovery will actually drive significant advancement in the field of star formation. Now, the really great thing is this is something we've not done yet. And the fact that it's a massive young star, it's in the Large Magellanic Cloud.
Okey-dokey.
And so, of course, yeah, if you want to see it, you've basically got to go down under. Good day, mate.
Yep.
I'm going to get shot for that one. But anyway, Dr. MacLeod is the lead author on a new article about the discovery. It's parasec-scale optical jet from a massive young star in the LMG. It's co-authored with researchers in Germany, the United Kingdom, and the US. It's published in Nature, which is one of the highest impact scientific journals. You better know your stuff because they will tear you to bits otherwise. The researchers say that the jet spans about 36 light years or 11 parsecs.
That's pretty far.
It's probably the largest jet of its kind ever found. Now, the star powering that jet appears to be about 12 times as massive as our sun. So obviously the data used for this work comes from the VLT in Atacama, which is amongst the largest optical telescopes in the world. It's getting to the point now where we don't need to go to space to image because you can go to Chile and go to the Atacama Desert, and they have telescopes which are actually completely mind-boggling. And they are still building new telescopes beyond our belief. There's the OWL, there's the twin, there's the binocular telescope, which is going to have two huge mirrors, and of course they're going to use an interferometer to actually get the image from the light. Now, this discovery is very important. It opens new doors in the field, and it also comes with a very rich data set and stunning images of a star forming region in one of our neighborhood galaxies. She's explaining that whilst the way in which stars similar to our sun are formed is understood, it's not the case for these masses 8 times out of the sun and above. Now, namely, these stars are so important in regulating star formation in entire galaxies, because basically when these things literally explode at the end of their lives, they seed interstellar space with literally with the elements you need for everything. And as Carl Sagan quite correctly says, we are all made from star stuff. If it wasn't for the first and second generation of stars, we wouldn't be here, because all the elements that were needed were seeded by stars going supernova. So the jet is a direct evidence for what they call an accretion disk. It's a disk around the equator of the star through which the star is gathering matter and thus growing, which is what we can see in low mass stars. The important things that are being found is direct evidence for an accretion meditative formation scenario for massive stars, meaning that we actually have evidence that massive stars up to 12 times the size of our sun form like low mass stars. It's the first jet from a massive young stellar object detected outside of our galaxy. In the Milky Way, most jet driving massive young stellar objects are invisible to optical telescopes. They're too deeply embedded in the stellar nursery, which shields them from our sight. However, in this case, both the star and the jet are visible in the optical. It's an unprecedented insight, and this is the first one that's ever been observed in optical light. Okay, it's the longest ever observed to date. It's 11 parsecs long. That is massive. Mm-hmm. And the way the jet was identified is unique, because it's only with the kind of instruments used to take the data, the Muse instrument at the VLT, this could be done. Regular instruments just would not have detected the jet. Now, just so you can work it out, the VLT can detect objects roughly 4 billion times fainter that can be detected with the naked eye. So Dr. MacLeod is one of the 11 University of Canterbury academics awarded the Royal Society Tepa Appering Marsden funding late in 2017 to continue her research on the impact of massive stars in the life cycle of galaxies, tracing massive star formation feedback in the nearby universe. Very important, very critical, and I take my hat off to her. This is incredible stuff, and it's really, really important that we've actually finally seen one without having to use radio astronomy. Mm-hmm.
They don't show an image for it, though. That's too bad.
Yeah, but you know what? It could be worse. Most of the time, the images that they do show are like
a generic star field.
Generic star. It's an artist's impression.
Yeah, exactly.
It's a plotted wave image showing. Like
they don't even have an artist's impression yet. I'm drawing one right now, and I'll hold it up to the computer screen.
But it is really nice. We're actually getting to these. We're getting to do the really interesting stuff, mm-hmm. and nobody ever thought they'd actually get to see one of these things optically. It's always been radio. Yep. That's always done it for us. But now, finally, we have optical evidence.
I don't think is this one ever. Well, they don't say if this one's ever been imaged in radio either, though. So that'd be something.
No, maybe, they don't.
If they did it first, in optical, then maybe they'll do it in radio. Or if they did it first in radio, and now this is the optical component.
Well, as I say, from the way I understand the article, is it is the very first detection of a jet from a very young massive star. I don't think they would have. If it had been imaged in radio wavelengths, then that would have been stated in the article.
Yeah, but then how do you find something like this? You can't be just scanning around the skies for something unusual when you're using like your highest resolution telescope system to get it. So I would guess that's probably something that's been known in radio first.
Maybe.
And then they went to image it in optical to see if they could pick it up. That would be my best guess at this one.
Maybe the fact its location lends it more to a first optical detection than radio.
Yeah, there's a lot of sky in the Magellanic Clouds, though. Was it the large one or the small one? Do you remember?
It's the large Magellanic Cloud.
Yep, that's even bigger. So definitely would be harder to just scan around even the large Magellanic Cloud and pick up a little hot spot that's kind of unusual. Where radio telescopes can actually do that.
But as I say, the nice thing is, of course, the images are digitized, and then they're looked at again. But you're looking at a computer screen. Mm-hmm. Let's be totally honest with this, folks. You would be looking at images on a computer screen. So basically, the image would be digitized, and then you'll be looking at a data set. You're converting it from from zeros and ones back into good old-fashioned analog, something you can see. Mm-hmm. But the fact it's been done is the most important thing. We found it. It's optical, and it's luckily in a spot where we don't have the Starbirth nebulae interfering. Mm-hmm.
So keep an eye out, everybody.
I'm told that there are images of the jet on the link. Black Projects is telling me that. So let me go back to this.
The link that Black Project put in, or the original one that the Canterbury one?
His links. He's gone straight to the actual paper, to the abstract.
Okay. Let's see. I was just looking
it's the RVXIX paper.
The Cornell University Library.
Yeah.
Paper.
Yep. It is the correct paper.
Okay.
So it's going to be on here.
I don't see it.
Submission history. So I'm just trying. I wonder if that's it. No, it's not. I'm actually looking on the link that Black Projects has given us.
Okay, I'm trying a couple of them. Yeah, me too. Yeah. Let's see. Here's something from Nature. Nope, it's not there either. New
email. Nope.
I was going to try that, but I thought, nah.
Let's see what's coming up. I'm pulling one of the ARXIV links up.
Okay, I tried some of those and didn't do it.
Okay. Mark. Okay.
All right, we'll leave that. Maybe Mark could find us an actual image of the thing. Page 4.
Page 4. Here we go.
Was there 4 pages? Let's see. Nope, I'm only getting the same one page.
Okay. Anyway, so we know it's there. We know the picture's there. It's on page 4 of the abstract. So why aren't we able to see it? Yeah.
Wait, there's a previous and then is that next and previous? Nope, that's articles.
Yeah.
Oh, okay. Nope, not there.
I'm just looking.
See something?
Other formats.
All right. So obviously, we're looking for this image. If we can find it, we'll get it into our chat. And if we get it into our chat, of course, we will also put it on our Facebook page, so you can get an actual look at this.
There is an image.
Stuff. There is an image.
I'm looking on the PDF version of the paper.
Okay.
There is a plot of it.
All right. So if you come up with it, then we'll pop it into our chat.
Trying to see if this is the right one. I'm trying to see. No, this is annoying because we know it's going to be there somewhere. It's not on that PDF I was looking at.
Keep going. I'll get into something else here for a little bit. The meteorite, as I said, the meteor that blazed in Michigan. Some they call them professional meteorite hunters have actually found some particles. And I see where they're looking, but they're holding them up. About a little bigger than thumb size, something like that, for a couple of them. Maybe 4 pieces have been found so far. I know the area. I've been through that area before. The picture of them holding them up says there's a lake in the background. So maybe they did like I was saying for everybody. If you want to look for meteorites this time of year, look on the lakes. Now, driving by that area today, most of the lakes are starting to melt down pretty good. And I don't know if I would trust the ice right now. So unfortunately, maybe missed that mark. I really need to catch up on stuff like that. I always wanted one to, come down close enough to me to go out and actually try to, try to hunt for some particles myself, but
Steve Arnold's got part of it.
Didn't get a chance to. Here's the article.
I've opened. What I've done, I've downloaded the PDF, and
on the star.
There are, and there are pictures of the. There are actually optical images showing it.
Mm-hmm. Now, just for everybody, like if you have a Astronomy.FM hard hat, so far they're working. Nobody's been hit in the head with anybody that's wearing a Astronomy.FM hard hat. And Glenn, I know I still owe you.
Now, as I say, you need to download the paper, which I just did, and yes, there are images there. So
can you put
enjoy it.
Can you put just a link to the images?
Let me see what I can do.
Or like a screenshot or something like that, and pop the image in for us.
I would then. Okay, where am I? 'Cause I'm in the wrong one now.
I wonder if anybody will be selling. Yeah, they're probably going to be selling some of these meteorites. Usually people like that keep one or two and then sell the rest of them. So hopefully somebody will find a whole bunch more just to bring the price down. That would be kind of nice. Finally, one close enough to me. And I was been driving in that area recently. So it's like, well, I'll probably not end up with any unless I, contact the collectors and see if they come on the market. They got to be cheap enough too.
Now I have that is a link to the actual PDF. So let me just click the link.
All right, I'll click the link.
Yes, it does. Yeah, you can now just scroll down.
Everybody will click the link now. We've built up the suspense of it.
Yes, and there you go. There is your picture. There is your optical picture.
I see a cloudy blob, which shrinks down to the next frame, and I think it had to take some processing, and I see it now. Oh,
so,
okay.
Yeah, that is an 11 parsec long jet.
Oh, from 180,000 light years away from us.
Mm-hmm. Impressive, isn't it?
And it's part of a nebula. Is that a? Well, that must be a nebula which is a cloud of gas, where there's star formation occurring right now. Then, in this area. So I have to look that up.
So interestingly, I'm seeing that there is a link to a radio to the HH 808180 North radio jet. So it may have actually been. Oh, this is just referencing the previous objects. So as I say. Quickly skimming the paper, it's been the NYSO Heribig Harrow flow reported here was detected in observations of the ionized star-forming regions LMC N180 from the optical integral field spectrograph MUSE. It's a bubble-shaped H2 region with a radius of between 2.5, looking about greater than. It's a large area in parsecs, 36 parsecs wide.
Yes, but what's the actual arc angle? I mean, how big does it actually appear from the Earth here?
Right. Okay. Let me see, because this quickly going to scan back.
Aqua is talking about. Not touching meteorite, if you want to. Well, that would be if you want to turn it into scientists. If you just want to collect the things and not, donate it to science. Then you just grab it. And
bag it, and take it home and get it checked.
Sell it, cut it in half, and and hopefully it is. Yeah, and you still have to be able to actually trust. The finders too. There's that possibility. It's happened before. Like, let's grab a couple meteorites from our collection, throw them in the snow, take a picture, and say, "Hey, we got it." It's a lot of stuff has happened like that. I've known some people that falsely claimed to have seen a.
It's an early Type B star.
Crash. Okay. So that should be pretty much a blue-white star. O is very white, like the 3 stars in the belt of Orion. I believe those are O stars.
The jet is highly collimated over the entire measured extent of at least 10 parsecs, and has a bipolar geometry.
Okay. But we don't know the actual arc seconds apparent size in the sky of that whole arc, do we?
I'm just dead impressed we actually managed to image it.
All right, maybe we'll find out sometime and let everybody know.
There'll probably be more being published about this.
Mm-hmm.
So as I say, Steve Arnold's got some of the Michigan meteorite, and
how'd you get them?
He actually went up. He took a meteorite men style trip up to Michigan and to actually hunt for them.
Oh, really?
Using the all the information that was provided. Basically, the information is available because a lot of people would have videoed it. There would have been some very accurate reports on places like American Media Society, IMO, as well, International Meteor Organization. So the trajectory would have been known, and if Steve Arnold, he's going to find it. he knows exactly how to work everything out. Him and Jeff, they would be able to sit down, they'd work it all out, they'd know exactly where they're going to go look, and I would probably say within 10 minutes they would have found it.
That's the thing about having done this before, having some connections and stuff like that, collecting enough videos, enough information, and figuring out pretty much where it actually came down. It can be kind of a tough part. If you watch the videos and you kind of can figure out where the area is, what roads people were driving on, watch the angle, and then look at videos from around the area. Obviously, some of the images, like the thing will be coming straight down. Yeah. Some of them, they'll be coming off at an angle. Now, some be angling away from you, some will be angling towards you, and if you could figure out where that dash cam was at that time, then you can kind of triangulate everything and put it all together and figure out where it should have come down at. It's a bit tricky. You got to get the information, and if you've got some inside connections to someplace that is used to tracking this stuff, not everybody gets the information.
Well, the thing is, though, a lot of it is public domain, and a lot of the CCT cameras that would have been used for this everyday security would have given you plenty of information. If you know where the camera is, if you know where it's looking, how it and what angle it was at, then you can plot the actual trajectory. Now, there's a lot of software out there. You can plug all this stuff in. AMS on their website will have the necessary tools for anybody just to go in on their smartphone. You plug your video in, it can work out. You can tell it that I was standing here, I was looking this way, this was the elevation, and that will actually take all that information, and it will give a very, very accurate plot. You do not have to be a rocket scientist. You just feed it into the website, and it will tell you.
You have to have that information, though. I mean, if it's your own phone, you can obviously say where you were standing at the time, plug that information in. You could say what direction you were looking, and go from there. But if it's other people's cameras, you got to locate where they were, or where the building was, or where the vehicle was on their dash cam in order to be able to figure it out. So moving dash cam, a little bit more difficult because you can't just say, like I-75 runs north and south. No, there's a lot of curves in that freeway. So sometimes you're actually traveling east, sometimes you're traveling west, and you can be pointing in any direction. So just being on one certain road doesn't mean that you're actually facing the same direction that the road happens to be generally traveling, and you got to get specific on that. So.
This is the nice thing about GPS. A lot of the dash cams now have GPS. And the thing is, and if you're using your own car GPS, you can get a readout of exactly your location, and that is information that you can feed in. Your mobile phone, if you have the location device switched on, which is a heck of a battery drain, but it can grab, particularly if you're using the apps, it can grab the GPS information, and it can actually work out the elevation. And so when you're submitting it, it's there.
If that information gets submitted, that information gets submitted somewhere.
Yeah, one thing we need to do before we go any further, because we forgot to do it, I just want to welcome Aqua for You, Horizon, there's Marty, Sunshine, Starstorm, Black Projects, Optronics, Glenn T, Astro, Dark Bishop, Quiet in the Woods, Cell BR, and Redshirt 3 to chat. Thank you, guys. It's great to see you here.
Yep. And if you want to come over to chat, anybody that's listening in, come on over to the homepage, Astronomy.FM, and you look near the top there, it says Radio Chat. Click on that. That'll get you to the login page. Type in your name or a handle, and then hit login, and you'll be here if you want to ask us questions or check out
Black
the link.
Projects has said it was 0.76 arc minutes.
0.76 arc minutes. I wonder what less. Okay, arc minutes actually pretty big. I was thinking of what's some of the planets. Double stars, I know arc seconds, a couple of arc seconds are pretty, like 2 arc seconds are pretty easy to split. So 0.76 arc minutes, 3/4 of 1 arc minute, like about 45 arc seconds. That's definitely seeable in amateur-sized telescope as far as the...
Yeah. Now, with that, Redshirt 3 has pointed out, PBS Nova had an episode on which detailed how they triangulated the Chelyabinsk meteor. Okay. So, as I say, this is probably, if you're interested, look up. If you're in the US, you can certainly go to the PBS site, and you can probably get the Chelyabinsk episode, and you can actually see exactly how they do it. And this is what Jeff and Steve do. This is part of the Meteorite Men philosophy. They sit down, they've got all the evidence from cameras, they know where the cameras are, they have the video stuff, they can actually, and they are using exactly the same information that would have been used to triangulate the Chelyabinsk meteor. So these guys are professional, and they are really, really, really good.
Yeah, so you hear about if you, like, you guys spend pretty much like all your time looking for new videos that have been submitted somewhere, and then start to work.
Yeah. Okay, so next thing on our news front, Humanity Star. Not another. Well, it's a bit of a failure so far, but it's another attempt to blight the night sky. Bad enough light pollution without putting another one up there. According to what I've seen so far, it's even fainter than an iridium flare. It's certainly at the moment much fainter than the ISS.
Or a little bit fainter than an iridium flare, but I don't think it gets pretty close to that level.
At the moment, you're talking plus magnitudes. Negative. They're saying this thing is supposed to be bright. There was a pass over London, and it was faint.
Well, plus magnitudes are like, a 1 magnitude star. That's a +1 magnitude. The North Star Polaris, that is 2nd magnitude. 1 magnitude, 1st magnitude are like the brightest stars in the constellation, like Rigel and Betelgeuse. Are, however, multi people pronounce it differently depending on your culture. So, I used to be able to do it with an Arabic accent. I can't do it right now. Betelgeuse. Betelgeuse. Yeah.
Yes, I had the course on how to pronounce it. People like myself and Black Projects, we grew up with Patrick Moore. And Patrick was a stickler for correct pronunciation of star names and of famous astronomers from the past. Of course, the other thing, is everybody calls it Tycho Brahe. It's Tycho Brahe, apparently how it's pronounced. So anyway,
it's all part of the country you're in. Like, England and French have a lot of same words pronounced differently. Trebuchet. Something else was like that too. Well, anyways, okay. Glenn wants to know what is plus or negative. We're talking about magnitudes of stars, for instance. So the brightest star you can see in the nighttime sky is approximately a 1 magnitude. The very faintest you could see with your eye is about 6 magnitude. That would all be on the plus side. So if you start out 6, barely visible to your eye, and good dark skies with great eyes, and go brighter and brighter stars till you get to a 1 magnitude star, which is really, really bright. And then if something's even brighter than that, it goes down to 0 magnitude, and then it goes into the negative numbers. Like, I think the moon isn't that like a negative 11, something like that, and the sun is a negative 23, 24, something like that.
Okay, so what I'm seeing here, for the 14th of March pass over London, it's rising at 18:49 in the evening. It reaches an altitude of 10 degrees.
Not very high.
Not very high.
Barely skimming the horizon.
Yeah. And it is... I'm just trying to see what they're saying for the figures, because I'm having to... It is very, very faint.
Mm-hmm.
The old iridium sats had the massive solar panels that really used to light up the sky. So you would see it as a light source that would start faint, then it would grow bright, and then it would fade again.
Well, different reasons for these things lighting up. Now, iridiums had, was it the solar panels or the antennas?
The solar panels.
Was it solar panels? I can't remember which one. It was really reflective, but being basically a flat mirror, they would only reflect sunlight in a specific spot on the Earth. Even no matter where it was going, even if it was straight overhead, doesn't mean the solar panels were actually aiming the sunlight down straight at you. In fact, usually not. So it was all about the angle of the sun, the angle of the solar panels, and where they would actually light up the brightest spot on the Earth. The farther away you were from that bright spot on the Earth, the dimmer it was. So if you're right in the hot spot, you might get minus 8 or something like that. If you're off 20 miles, you might be closer to 2nd magnitude. And if you're even farther, 60 miles, you might be down to like 5th magnitude, almost barely visible.
Yeah, so basically on the 14th of March, they're saying this thing's going to be at plus 4.3 magnitude.
Okay, about like Venus then.
It's going to be very, very faint. And saying it's going to light up the sky of the city.
Plus 4 is pretty dim.
It is very dim. But
inside of a city, you won't be able to see it.
Exactly. The idea is, of course, it's supposed to illustrate how fragile our planet is. It's just a piece of light pollution. I'm sorry. It's like that Russian solar sail thingamy they put up, and it was a complete disaster.
Here's a link to it in our chat room, by the way. Usually someplace on there that'll show you when it's going to be flying overhead. If you look at... Is it on there too? I put on the Humanity Star site. Now, if you look at the picture of the guy standing next to it, it's about 3 feet tall. So that means like every triangle on the thing, maybe 8 inches, something like that. So basically only one of those 8-inch triangles is going to reflect light right at you. The rest of them are going to reflect light off somewhere else. So you're not even going to get the effect of the entire 3 feet of mirror space shining at you. You're only going to get an 8 by 8 inch by 8 inch triangle shining at you, and that's not a very big spot at all. So
how can it light up the sky? Very, very bright, like the guy complains.
I promise. Yeah. Well, so the thing was easy to build, but not necessarily. The guy was not. Is he a rocket scientist or just some artist?
He's actually a rocket. They designed and built a test rocket. It's actually the first launch, I believe, from New Zealand of a proper rocket. This isn't a sounding. This is not quite. This is way above a sounding rocket.
Mm-hmm.
This is a very functional.
Orbital.
We can now get to orbit rocket. that was launched at New Zealand.
Low Earth
Of course, there's
orbit.
a lot of people tuning into launch to see if there was fried mutton chops going to be available for supper after the launch.
Mm-hmm. So it sounds like this was a lot more hype, obviously.
Yeah.
And it's proving to be a lot more hype than it is show, because just looking at the thing and how much light it could possibly reflect, that's not much. Like you say, an 8-inch by 8-inch triangle, mirror that size, 250 miles up or so, not going to reflect very much light at all. And it's proving it's not reflecting very much light at all.
Hey, Marty.
Yeah.
It's 9:45.
Is it past time?
9:35, yeah.
Wanna go for it?
Station. Go for it.
You are listening to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one happens to be January the 26th, 2018, 9:35 in the evening for those of us here in the eastern portion of North America. And that would put it at 2:35 Saturday morning, January the 27th, 2018. So we still have a little shy of a half hour more to go. Yeah. So stick around. Don't forget, we got our chat room open. Go to Astronomy.FM. Look near the top of the page where it says Radio Chat. You should find that. Click on that and hit the login, or type in a name, or do it anonymously, whatever you want to do. And you'll be in our chat room. You can ask us questions if you want to. And if we talk about links to specific articles or something like that, we'll put them into our chat room. We'll also put those links into our Facebook page. So when you're listening to the repeat...
You mean our website? We don't have a Facebook page for the Event Horizon. Only Space Pirates has that.
Don't we have Astronomy.FM Facebook page?
Yeah.
Don't the links go there? I thought the links went into our Astronomy.FM.
No, normally they go onto our website, but
on the website?
I'm having issues posting at the moment, so I'm going to have a weekend shortly where I'm going to do nothing but post.
Okay.
Trust me.
Speaking of the website, we are working on improving the website, so don't know when, but keep checking back on our website and see if you see some improvements coming up on our Astronomy.FM website.
Now, what can astronomers do when it's snowing, it's raining, or it's just cloudy? We could look
analyze
at the radio
data.
sky.
Analyze data.
You can process do some imaging processing, perhaps play around with a previous image and see what you can do to improve.
Watch sci-fi stories. And
also, the other thing you could do is set up your own radio telescope.
You can.
Now, how do you do that, you ask? Actually, it's very simple.
There is
a kit available from NASA, radio called Radio JOV.
JOV.
Now, what it does, it is a decametric receiver. You do need a decent bit of garden, because to do this, you've got to put some long wire antennas up. But hey, if you want to have some fun, hide them as part of the washing line.
How long of a wire would you need?
Still have washing lines. Hey, they'll run the wire underneath the washing line. Hide it that way. But seriously, what can you do? You can build the Radio JOV kit. You can set up a real radio telescope. You can make observations of the Sun, of Jupiter. You can actually even receive Sagittarius A. It is possible with this kit. You can take part in science with schools. Radio JOV it was originally set up to get schools into radio astronomy, but it's something you can do at home. But like I say, you do need a bit of a garden, because you've got to run long wire antennas for this. Basically, you're looking at around 40 megahertz. Jupiter is very loud. You can hear pops, clicks, ocean-like sounds emanating from Jupiter. So yeah, it's all good fun. Now, the other thing you can do, if you really want to have some fun, there's a thing called the Spider 230C amateur radio telescope. I'll put a link into that. Now, the 230 has been superseded with the 230C, and I'm waiting for my internet to catch up. Anyway, so it's from Primalus Lab. It is they actually offer complete radio telescopes. It's a steerable dish on an Alzheimer mount, and it's free shipping in most EU countries.
All right.
Can anybody still hear me?
I still hear you.
Hello?
I hear you.
Have I dropped?
No,
Hello?
Hello? Do you still hear?
No,
you obviously you don't
online
still hear me.
Okay, thank you. Okay, great. I just couldn't hear anything. I couldn't hear Marty or anything. And my link seemed to be delayed in chat. So anyway, one of the other things, this is weird. It's AFM chat has crashed. Okay, I can't. I can't hear Marty. Whoops, we're having fun here, folks.
Oh, we
anyway.
are. So who knows who
Okay,
to...
so you can also build a very simple radio telescope. crystalxxn.org.uk have a setup for you, and of course one of the UK amateur radio sites has a link. Now I'll put, this is just a simple decametric radio telescope for Jupiter, so I'll put that into the chat room.
Okay.
But don't worry, if you're not getting them from the chat room, I will make sure they're saved because I actually have them all. So basically, Bob Grief was observing visually with his local astronomy society, the Breckland Astronomical Society, with a 19-inch reflector, or his own 70mm reflector and 8-inch refractor. It often ended in frustration with cloudy skies, so he thought, how can he observe whilst clouded out? Well, he downloaded all the plans for the antenna and receiver. He did get some assistance. One of the club members was a professional TV and radio engineer and also a keen radio amateur. Yeah, I know. The page seems to have stopped. But so what he did was he actually built a 21 megahertz Jupiter antenna from an article by David Rosenthal. It describes the construction of a low-cost antenna designed to be used with a shortwave receiver to listen to Jupiter's decametric transmit emissions. Now, it does look like a very good way to start. So he went to Sky and Telescope, and he linked the antenna to a cheap multiband radio receiver with some ordinary television coaxial cable. Basically, he achieved that by removing most of the supplied telescopic antenna, and he fitted a coaxial connector in its place. There are plenty of articles. I will make sure they get posted on the website, but for some odd known reason, things are not just going to catch up in chat just yet. It's good fun. It allows you... Absolutely, Starstorm. You always notice a live show when something goes wrong. And right now, it seems to be the chat for me.
But you still don't hear me, though.
So I'm assuming that he's not saying anything. Sorry, Marty. One of the greatest things... You can probably hear Starstorm coughing too. But it's fun. Marty says, keep going, I will. Okay, so the other thing I was looking at was a Sky and Telescope article. And he's on his soapbox. Yeah, I'm on my soapbox. Thank you. So back in Sky and Telescope, and I'm just going to find that article now because it's been a while since I've been there. In fact, I know it's right at the beginning of the chat room. So let me quickly scroll up. And where is it? Where did you go to? I can't find the link anymore. Okay, I've lost the link. I will find all the links for later because I can do this again. So there was also an article in Sky and Telescope, primarily about the radio, aka Project JOV, and how interesting it was. To be honest, if you really want to do it and have some fun and you limited space, a dish would be a very good idea, purely because it takes the same footprint in the garden as a telescope does. So you just need to prepare a pad, a concrete pad. You put the pier in, set up the dish, wire it to the house where you would have an analog to digital converter. It goes into your computer. Then you can either record it on your hard drive, or you can even just put it onto use a paper recorder and put it into that. It's good fun. Chat is down. Okay, we are being told officially chat is down. Thanks, Rob. So it's something. It does take a while to get your head around and to actually build. Testing it. Contact your local amateur radio club or society. Even the ARRL has articles, and they even have some books on the subject. One was by a South African radio amateur. It starts off with fairly simple stuff, and it gets complicated. And so you're starting to head by the middle of his book. You are starting to head towards dishes, low noise amplifiers, and a real need for a computer to actually put everything on the screen for you. It's good fun. Maybe one of these days when I get really, really fed up, and I've got a few spare quid, I'll have a bash at it. But you can also, if you want to listen to if you have an old-fashioned TV antenna on the roof, wait and tune to a channel on UHF or VHF. And that's another way. Technically, you're doing radio astronomy. You're tuning in to part of the echo of the cosmic microwave background. The static you see on your TV is a part of that.
Visual representation.
It's a visual representation. Thank you, Starstorm. Oh, gosh.
It hurts your eyes.
Okay, spaceweather.com. Okay, let me just pull up that article. I'm going there as quick as I can. But, radio astronomer, amateur astronomer Scott Tilbury has a hobby. He hunts spy satellites. So a long-dead NASA spacecraft has woken up.
Curiosity.
Yeah.
Don't forget Curiosity. And that now iconic selfie.
Oh, yes. I'm just quickly reading. I'm just trying to see what the thing is. Yes. Basically, earlier this month, Tilly was hunting for Zuma, a secretive U.S. government satellite lost in a launch mishap on January the 8th. When a J-shaped curve appeared on his computer screen, he realized it was the signature of a lost satellite, but it was not Zuma. It was a stroke of good luck. What Tilly had actually found was Image. It was a NASA spacecraft that had died more than 10 years ago. Now, Image, which is short for the Imager for Magnetosphores to Aurora Global Exploration, was launched in the year 2000 on the flagship mission to monitor space weather. Mapping the ebb and flow of plasma around the Earth, Image was able to watch our planet's magnetosphere respond almost like a living organism to blasts of solar activity, while its ultraviolet cameras took gorgeous pictures of the Earth's global auroras. It had capabilities that no other spacecraft could match before or since, according to Patricia Reif, a member of the original Image science team at Rice University. It was in the 5th year of its extended mission in 2005 when the spacecraft suddenly went silent. Nobody knows why. Suspicions are focused on a power controller for the spacecraft's transponder, which might have failed. Just trying to see what else there is here, because
Could have also gotten hit with a bad blow.
it could.
Of solar radiation.
Yeah, it could have been. Yep, that's a good point, Starstorm. Thank you. I'm just trying to see, because I know Marty was pointing me to an article, radio article. Yeah, that was the one he was pointing me at. So, as I say, there's an awful lot of things you can do with radio astronomy. You can track satellites. You can even listen for the aurora. You can listen for Jupiter.
Meteorites.
Well, meteorites, you can use old-fashioned FM VHF transmissions, because normally with those you've got a case of it's when the ionization path in the atmosphere hits a signal, it will bounce the signal to a different location. Normally VHF FM is line of sight. So if suddenly you're hearing a signal from a station that you know is technically over your local radio horizon, then you know you're actually listening to an echo created by the ionization child of a meteor.
In the middle of Utah and you get something from like Singapore.
Yeah, that would be extreme. But
it's the same basic principle.
Exactly, same basic principle. Now, what else can we? Oh, the sunspot number for today. Let's do that. 0. So, spotless days. Total stretch of 6. The 2018 total is 13 days, 50% so far. Solar wind is at 431.5 kilometers a second. It's a density of 7.4 protons to the centimeter cubed. There's more data on ACE and Discover. And that was
just waiting for us to turn our backs.
Yeah, basically. X-ray solar flares, 6-hour maximum. There was an A3 flare on at 23:41 Universal Time in January the 26th. Yet still aurora, but with no spots. So this is funny. This is really fun. 24 hours. Another A3 flare. That was at 17:41 Universal Time on the 26th. More update on spaceweather.com. This is one of the great things. These sites are really fantastic because you can tailor it to your location, and you can then see what is going on for your area. The radio sun, is a 10.7 centimeter flux, 70 SUF. Let me just pull up an explanation for that. And
how about our Mars friend? Friend on Mars.
Well, the sky this week. Okay, Marty wants me to go to the sky this week.
Oh.
Right, okay, just 1 second. So let me just pull up the sky this week. It's going to take me a few seconds because... Oh, come on.
In the meantime, I'll talk.
Yeah, it's a live show, folks. We're having problems.
Nick doesn't know I'm actually talking right now.
I'm trying to
while he's looking for those articles, I'll sneak in a little bit of stuff here too.
Okay.
How about
Sky
that?
this week. So this week's Sky at a glance from Sky and Telescope, and this is for January the 26th to February the 3rd. The waxing gibbous moon, 2 days first past quarter, shines to the right of Aldebaran and to the lower left of the Pleiades this evening, as shown here for the middle of North America. So I'm on skyandtelescope.com observing this week's Sky at a glance, January 26th and February the 3rd. January the 27th, after dark, you'll see the Great Square of Pegasus sinking in the west, tipped onto one corner. Meanwhile, Ursa Major is creeping up in the northeast, tipped on its handle, or the plough handle, I suppose you could call it. On Sunday, as soon as it's fully dark, spot the big equilateral winter triangle high in the southeast under the moon. Sirius is at its brightest, and the lowest point, Betelgeuse, stands above Sirius by 2/5 at arm's length. To the left of their midpoint is Picron. Now, standing directly above Picron now, depending on your latitude, is third magnitude Commercia or Beta Canaris Minoris, the only other easy naked eye star of Canis Minor. On Monday, the 29th, look left of the moon for Pollux and Castor. Well, with Pollux with Castor over it, farther to the moon's lower right is brighter Picron, and far lower right. Ooh, that just did something. We've been kicked out of chat. Further far lower right of Picron is Sirius, brightest of all. Orion, high to the upper left of Sirius, is the brightest star of the 88 constellations, but his main pattern is surprisingly small compared to some of his dimmer neighbors. The brightest of these is Eridanus, the river to his west, enormous but hard to trace. Dimmer, Fornax, the furnace, to Eridanus' lower right, is almost as big as Orion. Even the main pattern of Lepus, the hare, cowering under Orion's feet, isn't much smaller than he is. Tuesday the 30th. Now, Pollux and Castor are high above the moon. Picron or Procyon, if you wish, shines to the moon's left. Now, we also have a total eclipse of the moon before or during dawn Wednesday morning, the 31st, for Western North America and Hawaii. Further east in Central and Eastern time zones, the eclipse is only still partial by the time the moon.
All right, I'll take over. So I don't hear Dick anymore. So I'll keep on going. So let's see. Got a couple things for occultations coming up tonight, tomorrow, actually. And let's see, from the is it from Iota? I can't remember. From Bright Stars or anyway. So the moon's going to go in front of a whole bunch. Yeah. Hi, Nick. How are you? Can you hear me? The moon's going to go in front of a whole bunch of stars in Taurus. Everything from Aldebaran, Omega Taurus, Gamma Taurus, whole bunch of them. But mostly you have to live in kind of the Canada, Alaska area. So if you're living in the high north of North America, you can see the moon. I
can't hear Marty at all.
You can see the moon going through Taurus. And yes, I hear. We're messed up again. I have. I hear Nick, but he can't hear me. So I don't know if you hear Nick at all either. So we're going to go on that way. Got a notice from the AAVSO, American Association of Variable Star Observers. There is a nova in the constellation of Musca. That's a very southern constellation. In fact, it's only within like 25 degrees of the South Pole, actually. Not too bad of a nova, about 7th magnitude, so pretty much any size telescope might, even pick it up in a pair of binoculars too. We'll be able to see it. So, especially like optronics, if you're living way down, you live pretty much far enough south there, you can actually look for this nova. A nova is a star, not like a supernova, where it actually explodes, but a nova is a star that actually gets brighter all of a sudden. A lot of times I think they're associated with twin stars, where one star is actually pulling material from a giant star next to it, and the material builds up on its surface, and then after a point, the star basically starts fusing that hydrogen that's on the surface of a star now, and it actually lights it up and makes it grow brighter, sometimes for several weeks at a time, and then it slowly starts to fade down. So not a big explosion like a supernova, but definitely a star that is getting brighter. So if you, for Southern Hemisphere observers, check that one out. Let's see, we've got some other articles to go through here. An astrophysicist proposes a new definition of planets. Well, we'll see if we can figure out what he's talking about here real quick. Well, a bit of an article to read here. I don't want to scan through the whole thing. We're only got a few minutes left here. So, well, how do you define a planet in our solar system, other solar systems? There's kind of a blend between large planets and almost stars called brown dwarfs. So, like Jupiter is a planet. It's a big ball of gas. I don't remember if it's actually emitting any of its own heat or not. If you took away the sun, would Jupiter still emit some heat? Maybe from its core, maybe not. But a bigger planet, a really big planet, right after it forms, it emits heat basically from gravity, squeezing all of its particles down together. And by squeezing it down, it basically makes all the stuff heat up. Now, only if there's enough stuff compressed together where you get a nuclear reaction, where you get fusion, and then it generates heat by fusing more and more material. But just shy of that process, right after a large object forms, it squeezes, causes heat, but not enough to cause fusion. Something right below the threshold of a really small star is called a brown dwarf. In fact, I think it was Hubble that just discovered a bunch of brown dwarfs in the Orion Nebula. Well, it's about time for us to get out of here. All right. Well, thank everybody. You got me back again.
Yeah, I'm back again.
Thanks, everybody in chat room. Appreciate you being here. Go on, Nick.
Captain Savick, the away team is ready to beam up. Let's get the three of us out of here. Good night, everybody.
Bouncing up and down off the planet for 10 minutes now. All right, everybody. Appreciate all listening in. Don't forget, we got Jodcast coming up and a new Talking Space coming right up after the Event Horizon. Thanks, everybody. Good night. Appreciate you listening in.
Good night, folks.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing.